Hello everyone, welcome back to my channel. Today let's go over a premium medium question that I just solved on my own. So I'm really happy about this because I guess I just played around with it a little bit and then was able to understand the question and solve it on my own. So I'm going to show you how I did it. Basically, you're given a matrix here and you want to insert exactly one interval of length k so that the whole thing has the least number of intervals. That means that the final array is the most connected it can be. So if you know how merge intervals works, this is very similar because basically if you have this and this, they're merged into 1 and 5, right? So 1 and 5 is the result of 1 and 3, 3 and 5. So you merge this and this. So if we want to find the minimum number of intervals that you can with inserting exactly one new interval, basically we would first sort this by the start time so that we know that this is the smallest, this is the largest in the whole matrix. So let's go ahead and sort it. And we go ahead and print intervals. So now you can see that basically what you want to do is take the current end time, add k to it, so 6. How many more intervals does 6 cover from the current point? Well, it just covers one more, right? So then you would say the whole thing minus 1, right? Because that's the best up to this point. Here plus 3, how many more intervals does that cover? Only one more. Again, 3 minus 1, so the best answer is 2, right? Here, for example, 1. Okay, from this point, plus 1 doesn't even cover the next one, so 0. So 3 minus 0, the best is still 0. This plus 1 doesn't cover up to 5. 3 plus 1 is 4. 4 is less than 5, so again, 3 minus 0, 0, so the best answer is 3, right? Okay, cool. So first, since we want to minimize the number of intervals, let's merge them first so that we don't have any overlap so that we maximize this. So let's go ahead and declare something called new interval 0. This is going to be the first sublist. And then we're going to go from 1 to length of intervals. And again, if this is less than or equal to this, then they can be merged. So if intervals of I of 0, because there's already sorted by start time, we're going like this, and then we're saying compared to the previous, if it's less than or equal to, then we merge them together. It's not in this case. So, but if it's less than or equal to new of -1 of -1, then we update that to be the max of itself, right? Let's say that this was 3, then since 3 is less than or equal to 3, then we would say this value should be updated to the max of this and this because we know that this is less than this. 5 is less than 6 because we sorted. And so intervals of I of 1. Otherwise, like in this case, then you just add the whole sublist because there's no overlap, right? So new.append intervals of I, and then you keep going. So let's print new. So in this case, new is the same. It's not really useful, but let's go ahead and now see how many intervals we can overlap. So answer 0 because we're going to say for n and new, we're actually going to binary search on the start and end times because we want to see 3 plus 6, how many more intervals can that cover? And it only covers up to the end point, right? So 6 here doesn't cover this because this is bigger than 6, whatever the farthest this place can reach. So it's like almost like jump game. And then now for n and new, let's say jump range is going to be n of 1 plus k, right? Okay, now we do our binary search, which we're going to do it on ends, right? So b equals bisect right on ends jump range. Let's print the current index. So how far can we jump from the current sublist? How many more intervals can we cover? We want the best result we can get. So let's print I and b minus 1 because bisect right includes the next interval, right? So here, as you can see, if we're on index 0, then we only can cover up to index 1 if we're jumping from 3 plus 6 is 6. Here, if we're jumping, in this case, the ends jump range would be 9. So again, the best is still only 1. We're at index 1. And then here, I guess this doesn't really make sense for this, but If you can see here, basically you just want to subtract the length minus the biggest difference, right? Let's print starts and ends, or let's print ends to give you a better idea of what I mean. So ends is this. So if the ends is 10, then bisect right goes up to 9. So it's not really accurate because this is supposed to be -1. But basically we just know that if it'll read exactly how many elements you can jump, which is the difference. So for example, if we did, let's try to get a better example here. So 1 and 3 is you can't jump anything. You can't jump anything, right? Here you can jump, but so you said 6 plus 3 is 9, so that we can only jump one more interval. So this is supposed to be 2, and this is the difference that we can get, right? So then here 2 plus 2 is supposed to be, well, 2 plus 3 is 13. It's out of range, so we're just going to do that. And then now answer is the maximum of answer, and b minus 1 minus I. If we print answer at the end, and again, it took me quite a while playing around with the test cases to figure this out. I did bisect left, and then I tried bisect right by myself, and then I tried starts and ends, but I figured this works at the end. So we just want to return length of new minus answer. Again, it did take me quite a bit of trial and error on my own, but I did figure it out on my own at the end. So oh, okay. So good example here. So now maybe we should do bisect left. Nope. Okay. Maybe we're bisecting left and starts, because starts is the beginning of the point. Okay. So again, just have to play around with this a little bit. Bisect right and starts. So including the current start means we're also including the current end, and there you go. Passes all test cases. Again, if we print this here, you trial and error through it, you'll notice that this is what works. So again, back to this example. I guess, yeah, what I had was wrong, because 6 plus 3 is 9. That includes the next interval. So we're at index 1, we can include up to 2, right? And then we're at 2, we can include up to 2. So this is what I was talking about. Had the wrong idea at first, but again, just trial and errored my way through it, and this is what I came up with. So not the most efficient, but again, did come up with it on my own. So thank you for watching, and stay tuned for more.